Hello everyone. Today we are diving into one of the hottest topic in the world of artificial intelligence, that is prompt engineering. But here the twist is it's not just about crafting a perfect question or instructions to the large language models. It's all about mastering the large language model capabilities, limitations. Additionally, you should know the technical specifications. So these are the few large language models which are currently using widely. And these are the key concepts of large language models you should understand to become a prompt engineer. Okay, that are like a specifications and limitations of the large language models. Every model has their own specific and the limitations are designed, and large language model parameters like a temperature, top K, top P, frequency penalty, and others. And also you should know prompting techniques and prompting models, basics of neural networks that are in a transformer architecture. And finally, you should know the ethical considerations like fairness, bias, accountability, and transparency. So, in order to understand the prompt engineering, we just brief about generative AI. Generative AI is type of a artificial intelligence technology that creates a new content based on the what it has learned from the existing content while it's a pre-training process. And also, in generative AI is a broader description of technology that leverages large language model capabilities to generate the synthetic data. The data can be text, images, audio, video, even code as well. Okay, let's come to the large language models. Large language models are also a powerful artificial intelligence tools that can understand user input that we generally call as a prompt and generate human-like text, images, audio, video, code, and recently we can generate a video using Sora. So let's bit more discuss about the large language models. The large language models are trained on a massive amount of data, which allows them to learn patterns and relationship between the words and sentences. This data can be include books, articles, code, and other text, and other image-based information as well. Coming to these large language models that are refers to a large and general purpose language models that are pre-trained on a massive data sets and can be fine-tuned for a specific kind of tasks for a specific domain industries as well. Coming to this pre-training process, the training an LLM on a large data sets to solve a general language task that are text generation, question and answering, document summarization tasks, or language translation, and more. When it comes to the fine tuning, it's adjusting the pre-trained model with a smaller and a task-specific data sets to focus on a particular use cases. Here, the particular use cases means industries like healthcare, medical, education, and more. So that are fine-tuned large language models are specifically designed to create a chatbots, generating a financial reports, script writing, or creative content productions. Finally, the large language models and generative AI are intersect, and both are subset of deep learning and artificial intelligence. The large language models are generative AI tools that are guided and utilized effectively through prompt engineering skills. So coming back to this prompt engineering, let's break down the prompt engineering. First of all, what is prompt? So as mentioned before, user interface with the generative AI models through the textual input in a general language. So we define the prompt as a natural language input to the generative AI model that are LLMs, where the user tells the model what to do. So let's have a small example. So this is a Gemini. We are just asking, translate, hey, hello, how are you? Just translate in the French. This is what the Gemini model has done the translation process. And coming to this, so in technical terms, a prompt is the input text or instruction given to the large language models that are like ChatGPT, Gemini, to elicit a specific reason response. It can range from a simple question to a detailed task descriptions. Coming to the concept of engineering, in terms of in the context of engineering in the context of large language models, it refers to a synthetic data design and fine tuning of your inputs that are prompts to optimize the model outputs. Okay. So when you are doing an engineering your input text, that should be very clear and specific, and also do a iterative testing and a refinement of the prompts. And additionally, the strategic design of your input instructions with a context and examples that helps to guide the LLM to get an desired outputs. Okay. And finally, we came to the concept of prompt engineering. The prompt engineering is an art of crafting clear and specific instructions to the large language models, ensure they generate a desired and coherent output. And also, prompt engineering is an essential for harnessing the full potential of generative AI models in a specific industries. Let's have a small example of prompt, a perfect instructions, as it is designed for a well prompt engineering. So this is the input we are providing to the LLM. Let's break down this. See, here, if you see this is the instructions we have provided, and specific and all this. This is how you should prepare your prompt or input to the large language model to get an desired outputs. So let's come to this understanding of large language model limitations and technical aspects. First, we should know the limitations. What are the limitations? Every large language model has their own and customized and specific limitations when you are doing practices. Coming to this Google Gemini, this is a Google Gemini model. It has some variants like a 2.0, 1.5 Flash and 1.5 Pro. So every variant has their own specifications and limitations. You can also go through this website, this URL. You will find each and every specifications to the individual variants. So these are the models available in Google Gemini with the specific instructions and the limitations. Coming to this ChatGPT's OpenAI, it has also a different variants with the different limitations. So every model is not same, and its limitations is also not a same. That's the reason we should understand every large language model's specifications, limitations, and capabilities to craft a perfect prompt to get the desired output from the LLMs. Okay. And tokenization. So this tokenization is a concept of when a user provided input to the large language model, the large language models are split the text into a small pieces that may be a words, subword, characters. I will show you a small example of this. When this is a dashboard provided by the OpenAI, how large language models are split your input text into split and convert into a tokens. So just I am giving every day. So this is just a simple word, but that is split into 2 tokens. This is how large language models are calculate your inputs, tokens. Okay. Rama Krishna. See this. So this name is split into 4 tokens. See this number of tokens. Okay. This is how large language models split your input text into a tokens that can help to solve the complex tasks by the LLM. And coming to the temperature. So temperature is determines how creative or deterministic the output will be. The lower temperature makes the response more deterministic and focused. Ideas for the task requires accuracy. And high value make response more creative and diverse. It may be sometimes affects hallucination also. We'll discuss about that hallucination later. We'll going to create the another video. Okay. So, and also another key parameters like top K, top P, and stop sequence. Where should LLM should stop the response without having providing any unnecessary contents, and context window. This context window is also a very important topic. You should know. The context window is a maximum number of tokens that respective LLM can handle in one attempt. For example, this is, let's take this. This is one window we have already opened. In this one window, context window, as per my knowledge, it's having some X number of tokens it can handle in a one attempt. So when it is exceeded the limit, it will lose the memory of the initial what we have requested. That is how the context window works. So that means if the context window limit is 4,000 tokens, the total number of 4,000 tokens, if you crossed that, if you reached and go beyond that tokens, automatically it's lost its memory, what you have requested or asked initially. This is how the context window works, and it's also a very important task. Another one is chunking is also there. Tokenization, chunking, and context window. These 3 combinations we should know so that we can understand how large language model responses are segregated. Okay. So these are, and also additionally, we should know encoding and decoding strategies. This is also very important topic that are involved in the transformer architecture. So the current large language models like ChatGPT, Gemini, Copilot, and other all major large language models are utilizing transformer architecture. Transformer architecture has encoders and decoders, and also that are to understand the patterns and generate the token sequences. Okay. And coming to one of the major prompt engineering concept, that is prompt engineering strategies. So there are different types of prompt engineering strategies that are instruction based, context based, and example based and role based. So in this instruction based prompt, the prompt should be very clear, precise instructions to a large language model to achieve an exact outcome. Okay. So for this instruction based prompt, I will go through this one example. So I'm just asking, I'm taking a new window. So I have given one URL to just summarize this. I just ask, hey, Gemini, just summarize this, providing the instructions, that is 150 words, focusing only on its key findings. Here the instructions are just finding the key findings and 150 words. Let's click on it and expect the output. It's generating the output. Yeah, see this. This is how large language models works based on your instructions. Instructions are also plays key role to produce the outputs. Okay. And coming to this context-based prompt, this context-based prompt are incorporating the situational details to improve the responses, relevancy, and accuracy. So context is also a key information in the prompt. That means in your input. Without providing your context, the LLM will provide the general information which is already pre-trained, which is already trained on. Simple. Okay. So that's the reason including context is also a very important aspect or element in prompt engineering. So let's take one example. Here I am just asking Google Gemini so you are a career counselor speaking to a recent computer science graduate interested in artificial intelligence but unsure which specialization to pursue. Please provide the, so here the context is, see this context, graduate, computer science graduate, interested in artificial intelligence, but unsure which specialization is to pursue. This is the context we have provided, and let's look into the response. This is how large language models understand and provide the information to the user's input. So coming to this example-based prompt, this is also one of the important to retrieve a most relevant information. If you provide an example, automatically by following that fewer examples, it enhances the memory and produce the best output. Okay. Let's try one example. See, I'm just asking, see this, 1 second, just crafting this. So actually, write a short and engaging introduction for an online Python programming courses. Okay. So use the following example. I have already provided an example how LLM should respond. In the example I have provided about JavaScript, but I requested about Python programming courses. Okay, just we'll see. See this, the same flow, the LLM produces the information about the Python programming. This is how you should include examples to train the LLM itself and to gain the accurate information. And also another important prompt engineering strategy, that is a role based. So nowadays everyone is most of the people are using this role based prompt also. When you are assigning a role to the large language model itself, it's create a content by involving itself as a role based. Like, so when you mentioned a role, it fits the memory into that role, and content will be generated as per the user's input. For example, let's take an example. You are an experienced financial advisor. Provide the investment advice for someone with a moderate risk aptitude. Okay, see this. So here the role is experienced financial advisor, and we are asking about the advisors. See, So the production of the content by the large language model. Okay. And also Google Gemini providing some suggestible links as well, which is already referred from the online. Okay. So this is how you should understand the prompt engineering strategies to become a prompt master in prompt engineering. And also the key concepts of prompt engineering that are called prompting techniques. Okay. So when it comes to the prompting techniques, these are also involves these are also play a key role in prompt engineering. So comes to this picture, come back to this zero shot. Zero shot prompting is a technique that large language model given input without any examples or specific instructions. It's like a general question asking. It's just asking a general questions, and the LLM provides the information what they relying slowly on its pre-existing knowledge to generate a response. We'll just ask a simple question to LLM, this large language model, like explain quantum computing in simple terms. This is just a zero shot prompting without we are not providing any examples and instructions here. So this is how LLM generates the response with the input. And zero shot prompting helps handle the task without need any supply examples, and also it provides a generalized information. It's for a general tasks. Okay. And coming to the few shot learning or few shot prompting technique, in this few shot prompting technique involves providing a few examples within the prompt to guide the model's understanding of the task. Okay. So few shot learning helps prompt engineers to achieve consistency and reduce errors in complex tasks where zero shot prompting may fail. It's particularly useful for generating a structured output or mimicking specific writing styles. Let's have one example. See this example. So here, summarize the following text into one sentence. Here is some examples. I have already provided some examples. This is the example one, and this is the question, and this is the output I have provided as an example. And this is another question input, and I have provided the summary as well. Now I am asking to summarize this ask. This is the input. So now let's see how it's going to respond. Google Gemini. See, so the new electric car model is prized for its efficiency and design. See this, what I have asked. The new electric car model has received widespread acclaim and its efficiency and design. And it's just summarizing this. The new electric car model is prized for its efficiency and design. This is how few shot learning works with fewer examples. Okay. So few shot learning is also a key concept when you are doing practice in a prompt engineering. Okay. And next one, fine tuning. This fine tuning process is very, very important and costly as well when the large language models are training. Okay, fine tuning involves adapting a pre-training model to a specific tasks or a data sets by training it with a additional and domain specific data. Here the domain specific data means different industries we have: healthcare, finance, legal, education, marketing, and more. So this fine tuning creates model that respond more accurately to the domain specific prompts. Here the domain specific prompts is very, very crucial part in the prompt engineering skills. Okay. So these are the key prompting techniques you must know in a prompt engineering skills. And also another important and widely used currently, the prompt engineering technique you should learn, that is domain specific knowledge on the domain specific applications. Here we have many industries like healthcare, legal, finance, marketing, education, customer support, software development, retail, and more. So these domain specific prompts are more crucial when you are into the prompt engineering. To become a specialized in domain specific prompting, first you should learn the domain basics. For example, let's take me, I am a digital marketer. So I have good knowledge on search engine optimization, Google Ads or PPC, and social media marketing and more marketing skills. So based on that, and additionally content creation. Based on my skills, I can try to create a prompts specific to the marketing. Majorly, we create a content for blog postings and for a client's presentations and moreover. Okay, so first you should know the basics of domain, or you gain into the knowledge, full depth knowledge of that specific domain. Okay, and also you should know the LLM behavior in that domain, in the specific domain. So observe that model respond to a domain specific queries and adapt prompts accordingly when you have a good knowledge on LLM behavior in that specific domains. And also interact with the SMEs, collaborate with industry experts to get the valid outputs. Okay, and also explore advanced techniques combining the domain specific prompting for a better results. So finally, if you are have a good knowledge on specific domain like a healthcare or finance or marketing or any other industry, this will also helpful to you to become a master in prompt engineering. Okay. And another important concept is prompt engineering models. These are also widely used prompt engineering models nowadays and are also trending. So these prompt engineering models are different or differ with based on your specific tasks. One is RAG, retrieval augmented generation. The retrieval augment generation combines retrieval mechanism with a generative AI models, and RAG focus on augmenting knowledge from the external sources to retrieve the relevant information by doing the semantic search. And also RAG is a LLM knowledge base. It acts as a LLM knowledge base. The primary motivation is to fetch the relevant information from external resources like a vector databases, which has a PDFs, Excels, documents, images, and moreover. This RAG system can effectively enhance the information retrieval functionality capability by doing a semantic search, and it has indexed the documents and chunked. So we already discussed about, we also should know about the chunking process. We should know, okay? Yeah. And another concept is chain of thought. This chain of thought is a strategy that encourages the large language model to break down your complex input, and it produces a step-by-step reasoning and a logical steps rather than just providing a single answer. Chain of thought is also one of the important tasks we should know. And another one is react, reasoning and action. So React is kind of a framework where the large language model combines reasoning, that is a step-by-step process that is actually happening in a COT, chain of thoughts, and additionally it's take the actions interacting with the external tools like APIs and databases. It alternates between the reasoning and acting to refine its output, access private and publicly available data sources. Private means it's again comes with the RAG, and public means over the internet. Both RAG and React using private knowledge bases, where React act as a smarter than RAG. It goes to a public resources and knowledge bases to bring the additional information to complete the response by the user input. Okay, these are the key and must known prompt engineering models while you are doing the prompt engineering skills. And also, you should understand the neural networks, basics of the neural networks. So why neural networks means, majorly these are when a user input passed through the transformer architecture, that is encoding and decoding to provide the responses. So how it works in behind. To understand that also, you don't need to dive deep into the neural networks, but it's a good idea to know the large neural networks that are recurrent neural networks, long short term memory neural networks, and convolutional neural networks and transformers. These are the neural networks you have to get the knowledge. Okay. And also one of the biggest challenges to the large language models, that is hallucination. So hallucination means that is type of a that's happening in the outputs actually. So when user asks a input, while it processing with the transformer architecture, passing through the transformer architecture, it's always looking for the what is the next token, the sequence of the next token. If it is not find the next token of the next sequence token, it may cause to reflect the hallucination. So it's you can think it's a when a person, it's like a daydream. Simply say, the hallucination refers to the phenomenon of where the model generates a text or information that is factually incorrect, nonsensical, or fabricated, even though it might be sounds coherent and believable. It's like a daydream by the human beings. So this hallucination is also a important concept in the prompt engineering. And also it is the biggest challenges to the all large language models, including Gemini, ChatGPT, Coher, Copilot, Bloom, Bet, and others. Okay. And also one of the most important topic you should cover, should learn in the prompt engineering, that is ethical considerations. These ethical considerations are why you should know about these ethical considerations means there is a concept called bias and fairness, safety, privacy, and transparency, and accountability. These are also plays a key role in prompt engineering to produce a desired output from the LLMs. Okay. In final words, prompting is not prompting is essential of harnessing the full potential of generative AI models in a specific industry. Okay. So while you are crafting a prompt, that should be very clear, specific, and maintain the structural formatting and should include the context. and also do the refining. Iteratively modify the prompt until the desired output is consistently achieved. Okay. So prompt engineering is about understanding a large language models and crafting the right prompt and leveraging large language models capabilities to tackle the real world challenges. Thank you so much for watching and staying with me on this journey of mastering prompt engineering. So I want to wrap with a few insights on that. Not only summarize, we have learning, but can also serve as a guide of anyone looking to dive into the trending generative prompt engineering skill sets. If you found this video helpful, go ahead, like and subscribe and drop your thoughts in the comments below section. Thank you.